Hello, everyone. Good morning, good evening. Welcome back. Welcome to Cloud and DevOps Batch 58. Before I start the session, I just want to give a quick recap on what's being covered in the previous session. Previous session, we are working more or less on the top of the bootstrapping. What do you mean by bootstrapping? Okay, when a cluster is coming up, okay, what are the values that you want? Okay, so as a part of the cluster provisioning, I want my I want my ingress controller should be deployed. Okay, why do I want to have my ingress controller deployed? Because we are going to have a lot of entities. Okay, so the reason why we want an ingress controller is because we want to expose our application, right? Ingress controller. Okay, because we want to expose our application. Okay, and the LB service, the NLB, okay, is deployed on the top of this NLB. Okay, on the top of the public service. And if you want to expose it, you need to have an ingress controller, right? Now, we did it. Now, likewise, okay, we also want to expose our applications, right? The front end of the application. So for that, we'll create a front end ingress. Okay, likewise, on the top of the same cluster, okay, I also want to have my Prometheus deployed. Okay, so Prometheus, I also want to have my deployed Prometheus. Likewise, I also want to have my Grafana deployed. Whatever the topic that I am going to create in my entire 8 years of my career, I only got once or twice to create the OADC. Okay, most of the cases, the chief engineers or the architect will design and create the OADC provider, and we just consume it. Okay, so I'm gonna show you from the thumbprint, from the trust, IAM role creation, everything. Okay. Now, whenever you create an ingress resource, okay, this is how it resource, right? Ingress resource. Okay, whenever you create an ingress resource, so you mentioned the host name, right? Host name. Yeah. So what it does, is, for example, if you go to ingress.yaml, okay, so I'll just say Prometheus. Okay, if the requests that are coming from Prometheus dot cloud apps dot today, then I want that request, okay, should be forwarded to the service, okay, whose name is Prometheus for the port 8080. Okay, so whenever you deploy an ingress resource, okay, so this creates a DNS record for whom? Okay, so so what we need to do, we need to create a DNS record, okay, for the ingress load balancer as CNAME. If you remember, in the last session, we are doing this activity manually, right? What if you have 10 resources that needs to be deployed? Okay, what if you are going to deploy few resources and it happens so quick? Okay, if this is the case, what you need to do? You manually go and create the DNS record for the load balancer, right? Okay, this is a very brand new concept. There is a concept called as external DNS. Okay, the functionality of the external DNS is, so let me go to the board. I want this because we we provision the clusters on the day-to-day basis, right? I want to make sure external ingress, external DNS. Okay, this ensures, okay, ingress resources that are provisioned for Grafana, Prometheus, Help, and front-end component. Okay, DNS records Okay, but for this to happen, there is a lot of things that needs to go through. So let me show you. Okay, external DNS. So SIG stands for special interest group, people who are interested in Kubernetes, who want to develop the tools. So they form a community called a special interest group. So who maintain a lot of tools. Mongo external DNS is very fancy thing. So what is the idea behind it? External DNS synchronizes, okay, Kubernetes services and ingresses with the DNS provider. That means whatever you mention in the ingress resource, the appropriate resource against the mentioned load balancer will be created on the top of the DNS provider of your choice. And if you are on Google Cloud, Cloud DNS. If you are on AWS, it's a Route 53. Okay, so it supports. So what it supports, okay, so it's going to deploy. Okay, so let me show you architecturally. So for this to work, what will happen here is, okay, you deploy an ingress resource, right? Likewise, we'll also deploy something called as an external DNS as a deployment. This needs some authority. All these things comes up. Okay. Now, whenever you deploy any ingress resource, this detects the changes. Okay. This this detects those changes, and then automatically it connects with the cloud provider that you have mentioned. Okay, Route 53 hosted zone with the zone that you have mentioned. Okay, I'm talking in the context of AWS because we are on AWS. Okay, if it is Google Cloud, it's Cloud DNS. Okay, so it automatically connects to this guy and provisions the DNS record on the top of it. Okay, for this to work, you need to, okay, for this to work, this deployment which you have deployed need to talk to this, you need to have authentication enabled. That means you should have the needed IAM roles. Okay, and that IAM role should have the needed permission. So for enabling the communication, authentication from this particular deployment on Kubernetes to the Route 53 hosted zone, which is a service on AWS, on the top of IAM, okay, you create something called as a OADC provider. Okay, and then we'll enroll our EKS and the service account of the deployment, not everyone. Okay, so this is what we are going to do. Okay, again, as I mentioned, in my entire career, I only did this once or twice. Okay, because in any project, once you set it up, that's it, everyone uses it. Okay, this is very, very important. Even in your resume, you can mention that I have configured OADC provider. OADC stands for OpenID connectivity. This is for enabling the authentication and authorization between services. You can think, okay, I'll download the service account keys and I'll supply it, then it can directly talk. No, in 90% of the organizations, you cannot download the keys. Okay. All right, clear? Context is clear, everyone? What are we going to achieve? So end of the session, when I deploy any ingress resource, the appropriate DNS record should be created on the top of my hosted zone. That's the goal. Okay. So let me delete unwanted records and all so that you can easily look at it. Done. Done. Argo CD, that's Cloud App Studio. These are something that I have created. Okay, all right. Done. Now, if you want to create this documentation is very clear. So this is what I want to do, right? So let's try to add this information. Yeah, I'll upload it later. Okay, this is what I want to add, right? So just a second. Let me. Can someone confirm me? Am I audible? Check. Check, check. And can someone confirm me? Am I audible?
Yes, Manoj.
Okay, all right. Okay. Okay. This is what we want to do. Okay. Everything we want to do it through Terraform. Okay. This is something. It's a very good thing to add it on your resume as an achievement. Okay. Let's start from the scratch. So here they have clearly mentioned if you want to deploy this, so go to the charts and in the external DNS, they mention before you can start, you need to add the external repository. This is something you have to add, and then you need to install it like this. Done. And then once it is done, again, I want to do everything on the top of the system namespace. Okay. As I mentioned, I want to do everything on the top of. Okay, what do you call? I want to do everything on the top of this. What do you call? Yeah, on the top of Terraform. So here, all the configuration files, I think it's better you move it to a separate file. Move this to conf and the bootstrap. Done. Now here, I want to in case if I want to supply any values. Okay. Now, as a part of the bootstrap, I want to deploy one more resource. Okay, deploys external DNS. Okay. In the kube system namespace, this is external DNS and always trigger at this point of time. Yes. Done. This has to be done. Okay. I also want to make sure this gets provisioned. Okay. I want to make sure this gets provisioned after I deploy this. Okay. So I'll just say null resource dot ingress. Done. Okay. So let's try to add it. Add the repository. Done. Now what this means is it is going to download the particular chat. Okay. And this is the name of the repository you're adding. And then again, these charts will have, okay. Done. So it's going to connect to the Kubernetes cluster and authenticates, and it's going to download the repository. And then you are going to install the external DNS component from this particular folder whose chart name is this. Okay, and this is the name. Okay, you are installing a chart whose name is external DNS, which is available in this particular folder. And again, even these charts are supplied in multiple paths, multiple versions. So you're specifically mentioned that I want a chart whose version is this. Okay, that's it. Next is I want hyphen namespace this. That's it. So it's going to be created on the top of it. That's it. Done. Anything else? That's it. This should deploy the Nginx ingress controller. Anything else? External DNS, deploys external DNS. Okay. This will ensure ensure needed DNS records would automatically. See, if it is a resource that is created on the top of just your cloud environment, then you can use Terraform. But you are creating a DNS record for the resource that is created on the top of the EKS, okay, which cannot be just done by using Terraform. Okay. So yeah, perfect. Let's deploy it. Okay. Let's call it as deploying external DNS. Done. Now this should download that and it should apply. Let's wait. Perfect. You can also see external DNS doesn't exist, so it's installing. So I'll just say helm list -a. You should see external DNS getting installed on the top of it. And if you see kgp-a, you can see external DNS got deployed. Okay. Now, okay, done. KLF. Okay, core DNS is a DNS service on the top of your cluster, but external DNS is to create records on the top of your Route 53 hosted zone or cloud DNS. Okay, so done. Perfect. Now I want to see whether it is really working or not. Okay, so let's try to do one thing. I have an ingress file created, right, just for the purpose of it. So what I'm gonna do is I'll go ahead and try to see whether it can really create or not. I know it's not going to create, but I'll show you something. Okay, so here what I want to do is not Prometheus. Okay, done. And I want this request. Okay, just sampling this. Okay, and it should be sent to a real service. All right, let me do it. I want to send this request to some service kc get svc-n. Okay, let's deploy this to this particular service which is available here. Okay, service, and it is working on port number 80, so I'll just send it to 80. Done. So you also need ingress class. All right, so they have given you an example here. If you see this, if you want to create ingress class name is equal to nginx, because we are using one nginx, it's under the spec. Done. And you can also use rules host name which you are already using. Done. But I wanna tell this is inside the kube system namespace. I want to show you some error. Okay, so ingress this, and it is going to send the request to this. Actually, there is a, let's add this annotation, okay? Okay, so that's it. Now let's try to create this. The expectation is when you deploy this resource, B58 public, it should create a record directly on the top of this, okay? That's the record, that's the expectation. Done. Okay, so let's wait. So this can only create once the, okay, so here this particular record is supposed to be created on the hoster zone, but that can only happen once this address is assigned. That means in the backend it is get still creating. Let's wait. Yes, perfect. Okay, now let's try to see KGP. Now external DNS. Can you see this? So failed. And the reason for this failure is, okay, that means it is attempting to go and talk to the Route 53 hosted zone, but it is not having the authority list host zones, no credential provider, okay, no valid credentials in chain, but at the same time, no credential provider. Who is the credential provider? OIDC, okay? So who provides the credentials, okay? So for this service, which is running here, to talk to Route 53 zone and create, there should be some credential provider, right? Here, OIDC is a credential provider. That means you need to create an IAM role that should have the authorities needed. And at the same time, you need to mention that this pod can use it. So you need to create an IAM role. You need to enable the trust. You also need to supply the needed roles. Okay, that's what I want. But there is no rocket science. Okay, they clearly mention what all roles, all these needed, everything has been supplied here itself. So the external DNS itself, there is a page. Okay, docs, go to docs. And inside of the docs, go to tutorials. And we are interested about AWS, okay? If you are on Azure Cloud, if you are on Google Cloud, is a different story. Okay, but I'm only going through AWS because my resources are on AWS. This tutorial describes how to set up external DNS for usage within a Kubernetes cluster on AWS. Make sure your Kubernetes cluster version is this. I'm using 1.30, so no, this one. Okay, this is the IAM. Okay, this is the document that you need to use to create. Okay, so this is something that offers these roles. Okay, what it means, this means this gives list hosted zones. Okay, and list resource tags and these three permission, and these are the permissions that you are getting on whom. Okay, on whom you are getting these permissions, on whom, on this particular hosted zone resource. I'm not just mentioning cloud apps today. Whatever the resources that I create, if I own that domain, it should create. Okay, it also has the power of changing the records. Change means update and create. That means to allow. So this is the IAM policy to use. Okay, so for this IAM policy, you also need to have an IAM role and the trust policy. See what else is needed. Okay, let me collect all this. Okay, this is IAM policy. Left. This is the IAM policy. And next, you need to create an IAM role. It's a pretty big document, by the way. Okay, so the next is use AWS CLI with any, otherwise we can do the steps. Okay, done. This is something which gives the trust. Okay, so you also need to mention this means, okay, so the particular principle, okay, OIDC provider is nothing but, okay, for each and every cluster when you provision, okay, you are telling who is the subscriber. Okay, it's not like it is the OADC provider is going to give credentials for everyone. No. Okay, you have to mention, okay, this is the resource. Okay, each and every resource on AWS, if it needs authentication, that should support OpenID. Okay, so this is the OADC connector. So this URL you need to supply to this guy, saying that credential provider can be given to this guy. Okay, and then action is like assume role, web identity, and strings. Okay, OADC provider, you need to mention, okay, on the top of the Kubernetes cluster, okay, which is nothing but this particular cluster, OADC. I'm interested in providing, okay, so I'm going to give the needed authority to the service account that is available in Kube system, whose name is external DNS. That means you are giving permission. Okay, so this particular deployment is running with the service account called as external DNS. Okay. Again, as I mentioned, it's tricky. No one in the company would be knowing it. Okay, one of the other person will do it, and everyone uses it. No one know how to work on it as well. So make sure you understand this. Okay, if you don't understand, watch it one more time. If not, ask me. Okay, so this particular service account should be given the needed IAM role permission to talk to this guy. Okay. Sorry. So OADC, this is the subscriber, and audience is this. Okay, AWS, if you are using AWS, session token service is the guy who can talk and get the credentials. Okay, this is also something I would need. Okay, so first let's try to create an IAM role. Okay, so this is also something, let me get that. Okay, this is a trust, by the way. Trust. Now you need to create an IAM role. So this is how you can create an IAM role, right? IAM role plus trust for external. That's done. I'll call it as external. Okay, var dot component. I'll call it as EKS. Try to make names as explicit as it as possible. So here in the assume role policy, so we already have it, which I got it from here. I'll just copy and just paste it. Okay, done, done. Okay, now what it does, so this particular IAM role is going to be created, which has the trust. Okay, that means this guy is authenticated but not at authorized. Trust is like enable authenticity. That means you are creating a role which can be used by these guys. Okay, so yeah, so here external DNS, this default done. So you need to supply these values as well, OADC provider. Okay, so this OADC provider value and account, you can get it from this. Okay, so how do I get the OADC provider? Okay, and how do I get my account ID? There is another thing. Okay, I don't want to hard code it because this is a module which can be used by others in the organization as well, and they can have multiple accounts. Okay, so next is we need to create an OADC provider, as I mentioned. It's a service in IAM. So here you have something called as identity provider. So which provides credentials to the verified identity. So here it's not SAML based authentication, it's OADC based authentication. This is to enable the trust. As I mentioned, trust is nothing but enabling the authenticity. Okay, establish trust between your AWS account and identity provider services such as your Google or Salesforce. For example, if the services on Google wants to talk to AWS, this is the provider you need to use. So this provider URL is nothing but, okay, so in our case, this is the OADC provider that we need to supply. And then audience. So audience is our session token service. So STS dot Amazon. And then you need to click the provider, but I don't want to do it through here. So I want to do it from the code. Okay, how can I do that? Okay, so go and try to ask. OIDC provider, provision OIDC. Done. This is also something we are doing it. AWS, where is it? I am OpenID connector provider Terraform. Okay, this is how it looks like. Again, thumbprint. Thumbprint is, okay, thumbprint for each and every account, there will be a thumbprint, okay, to prove the authenticity. But I don't want to hard code it. Okay, this is common for every account. So you take my account, even if I create 100 resource, the thumbprint remains the same. That means in this particular account, this is the resource, okay, which can use this OpenID connect. That's what it means. Okay, so go here and try to create OIDC. Done. I'll call it as a main. And then URL. This is like you are creating, assuming this is for AWS. In Amazon, it's how do I get this URL? This URL is this. Okay, as I mentioned, this is the URL. Okay, this is what here it expects. Okay, that means you are creating an identity provider for the Kubernetes cluster, which is available in this account. But how can I give that? Okay, not here, client. At this. One second, let me get it one more time. Okay, so here for each and every AWS account, we'll have a thumbprint and client. So here in our case, client is session token service. Okay, and URL. So in our case, this. Okay, so in our case, OpenID connector. So that which means we are creating this for this particular guy. Okay, but I don't want this particular information and this particular information. I want to do it through Terraform. Okay, so this particular information, again, I can hard code this particular value, but I don't want that. Again, if the same code should work, if someone creates an US central one, this code will break. So I don't want this. So how can you get that is Terraform CD2. Okay, Terraform state list is a command which is going to show you the list of state files that are created by this repository. And in this, if I see the state of AWS EKS, I should get some information. I'm interested about EKS, right? Terraform state show. Okay, this is how you can read information from state. Okay, it is expecting the entries in quotes. I just want to see how the information is coming so that I can directly read it. Okay. AWS. Oh, I am not interested about VPC. I'm interested about EKS. Yeah, this is what I am interested. This should show all the properties of it from the registry of the state file. Okay, done. Now here, for this particular cluster, there is something called as identity. And under the identity, OIDC is a list. Okay. So identity is a list, and under the identity, OIDC is a value, and under the OIDC, issuer. That means for identity, 0th item, and for OIDC, 0th item. I can say data dot. Okay, maybe I can say AWS cluster dot main dot OIDC identity dot OIDC dot issuer. Okay, let me do that. AWS cluster dot identity 0 dot OIDC is also 0th item dot issuer. That's it. I got the issuer. So this works in any of the environment now. So even if you take it and work it, it won't break. You can bluntly take it and use it. Okay. Next is thumbprint. How can I get the thumbprint? I'm gonna get it. Just a second. Someone is. So how to get this information? Okay. So whenever you want some sort of information, okay, see, that's thing. Let me update the comments. Okay. So we are working on this. So let me try to do that provision. How to get the thumbprint. Okay. So there is a tool called as a Kubergrant. Kubergrant. Okay. This is a hybrid tool used by Terraform to get the information from Kubernetes. Okay. This tool, this helps. This is a Terraform tool. This helps Terraform to fetch the properties of the this can help. Okay, see, this Kubernetes is a tool that is created to bridge the gap between Terraform and Kubernetes. Okay, it is a native thing. Okay, it is a native thing to Kubernetes and Terraform. So we can use it. I think we have that Kubernetes installed. Even in your missions, you should have it done. Kubernetes is already there. So let's try to see how to get it. Again, I can hard code it, but that's not the right way. Okay. Okay, come here in their GitHub page. Yeah, as I mentioned, Kubernetes is a tool that is created by Gruntworks to make Terraform easy to integrate with Kubernetes. That's the idea behind it. It can do a lot, by the way. And I'm interested about the thumbprint. Yes, OIDC thumbprint. So Kubernetes EKS. Okay, so Kubernetes EKS OIDC thumbprint issue URL. Okay, done. So this is how I can get it. So issue URL is this, right? This is issue. Perfect. You got it. Okay. So maybe we can use it. Okay. So how can I use it is the next thing. Okay. So done. Let me try to add it in the comments. Okay, this is how typically in organization when you're working on something, you work on it and try to add the comment so that your next engineer can also use it. Okay, so just working real time. Done. Done. Okay, now so we need to integrate that. Okay, so how can I run this? So how can I run this command? Okay, maybe we can use some external. So whenever you land into the situation of running something, okay, where you don't have a resource, okay, either you can use null resource or data or external. Okay, okay, this is especially the data external source allows an external program. I'm telling you, external program implementing a specific protocol. Okay, it's more or less like a null resource. So use this only mechanism as an escape hatch. So when you don't have anything which cannot be solved by Terraform, then just use this. Okay. So go here and try to say data.af. Then data dot this one, I'll just want to call it as so what is the command that I want to run? This is the command, right? Done. Done. Next is share URL. And this one. This is something you can get it from. It's a URL. Okay, so see the main idea behind it is I can, if I'm compromised at certain point, okay, most of the things I can do it, but the goal is if this code is taken by other project, it should work. That's how managers work. Okay, if you build something, your team will work. Okay, I'm paying this much. If I want to build one more project, do I really need to pay one more time? Why can't I reuse it? Okay, this will give the information. Okay, now how to read this information? It tells you. Okay, so the map of the string, a map of a string written from the external program. Okay, so result. Okay, so from result dot thumbprint. Okay, done. So if I want to add the value, data dot external dot OIDC thumbprint dot result dot thumbprint. That's it. You get it. Okay, go to the OIDC provider. Now I don't use it anymore. That's it, done. Okay, now data dot external dot OIDC thumbprint dot result of this. That's it. Now this should provisions OIDC provider. Okay. Okay, done. That's it. Now they should provision. Guys, is it clear? Interesting? Clear? Anyone? Ambit, clear? Sailaja, Rachit? You can upfront say this in your resume, guys. If you practice this, if you do it, if you put in your resume, trust me, the person who takes interviews also won't be knowing these sort of things. Okay. As I mentioned, only one in the company will does it and they'll tell you to use it. This is another thing, IAM rules, right? For now, I'll just comment it. Okay. Some patchwork is needed. Can someone confirm me? Am I audible? Mrudula, Arun, Srilata, Shailaja, Rachit, Mahendra, Girisha, Ambit, anyone?
Yeah, it's audible.
Is it clear, by the way? Does it make sense what we are doing?
Yeah, it's clear.
All right. See, OADC provider is just like an authenticator. Okay. So Active Directory is to authenticate you, right? So likewise, OADC provider is a credential distributor. Okay. For that to work, okay, for that credential provider to give you the needed token, you need to prove who you are, right? All right. So it should provision OpenID connector. Now go here and try to go to IAM. Refresh. You should be able to see. Perfect. Okay. Now you can see OpenID provider and the audience is this. That means session token service can get the token. Endpoint verification. Okay. This is the thumbprint of it. Okay. So which is the same as. Okay. Perfect. Okay. This is the. That means endpoint verification. This is the guy who can talk to the OADC provider using STS session token service and get the token. Okay, that means he can use. That means only this guy can use. Okay, so yeah, this guy is authenticated. This guy is enrolled. Now, next thing is, okay, we need to provision the IAM role. Okay, all right. So let's do it. Next is to provision the IAM role. The reason why you need an IAM role is, okay, so what we are going to do is we are going to map the service account external DNS, okay, external DNS, which is tagged with this particular deployment with the IAM role that we are provisioning. So that way the service account will get the needed IAM role that can talk to the Route 53. Done. Uncommented. So AWS account. So you need to find how to get the AWS account information. Again, this OADC provider, I need to use it multiple times. So don't you think I can declare it as a local? This information is needed. And if you see this, it is expecting OADC provider. That means this particular value, this particular string. Okay. This particular string is needed. Okay. If I use split function in Terraform with this 1, 2, 3, 4. Let me see how it works. Okay. Terraform console. There is a function in Terraform. Terraform split function. Okay. You can mention the separator followed by the string. Okay. Okay, perfect. So split. Comma. So 0, 1, 2, 3, 4. Fourth element. Okay, done. I'll just say 4. No, fourth element will be printed. So this is what I can use. So what I can do is I can use a func local okay. ORDC underscore. And this one I don't want to hard code it. Because if you destroy the cluster and you come tomorrow, this is something different, right? Done. Okay, now I can use wherever I want this. I can say local dot OADC provider. That's it. I can use it everywhere. Now go to the IAM role. Can mention it wherever is needed. Okay. So here, OIDC provider, you can just change it. Done. OIDC provider. Where else? Even here. Done. Okay. Okay, you can supply the OIDC provider. And here, account ID. How do I get the account ID? Okay, this is my account ID, but this can be run anywhere, right? If you just copy my code and use it, it should run. Data source AWS account. Okay, so you can just use it. And if you want account ID, data.aws account.current ID. Okay, done. And if you want, you can directly use it. $of data dot. This will give the data dot. Okay, done. So anything is missing. That's it. This is something. So here, which service account you want to give, that is also something you need to mention. So this is system service account. And in that, I'm interested about. I don't want to, I'll hard code it because I want this to be on the top of kube system because I determined it. Okay. System service account and kube system external DNS. Okay. So that means this is how we are, excuse me. So this is how we are creating the trust. Okay. So what we are doing, we are telling external DNS service account that is available on the Kubernetes clusters kube system namespace. Okay. Can connect to this particular OIDC provider using the token service, STS token service. That means this is the trust we are creating. Okay. Now, next is how come this will get the policy? Okay. We created a role and policy. We created a role and a trust. How about the permissions? Okay. So permissions are also needed. So first, let's try to run it and see whether it works or not. I'm still skeptical about it. Exit. So if it works, I'm happy. So next things are quite straightforward and easy. Perfect. So trust is like authentication. Okay, who can use this role? Okay, so done. You can see this particular IAM role was provisioned, whose name is this. Done. Perfect. Again, I have not added the permissions. Policy is nothing but permissions. What permissions are you? But trust is there. Okay, so this means this particular service account, Cube external DNS service account in Cube system namespace can use it. Okay, can connect to this particular OIDC provider. But after connecting, what it can do is something permission does. Okay, let's try to offer the needed permissions. Again, this is already there. If I'm not wrong, I copied it, the draft, right? This is a trust. These are the needed permissions. Okay, so IAM roles. Maybe you're already using it here, right? We can also use assume role policy. Either we can use the policy attachment. We can use something called as Go to IAM role. There is something called as inline policy. How to attach IAM role? Yeah, you can use something called as inline policy. Okay. JSON decode. You can directly use this. Okay. The one that I got drafted. Okay. Done. Okay. So this inline policy. So you are creating a role along with the trust saying that who can use this role. And at the same time, you are offering these three needed roles. Okay. So this should suffice. Okay. Trust. So if you are working for smaller scale companies, okay, they might think if the development effort is taking 1 week of time, hey, creating the DNS record will take 1 minute of time, right? Why do I need to invest 1 week of time? This is a non-development mindset, okay? So when you're working, keeping scale at mind, okay? So even 1 minute of effort can be automated is very nice thing to have, okay? That's what bigger companies and development centric companies will look to. Done. Go for it and try to refresh. I think last but someone has asked me, okay, if it's just a small thing, right? Why are you spending 45 minutes of time? Perfect. Needed permissions are there. Now should be good. Okay. Let's see whether it works or not. There is some more thing we need to do. Okay. I'm sure it still will not work. Okay. Hmm. See. It should not work. Okay. I'll tell you why. Delete this. Let the detect. Okay. Okay. This should provision. Okay. It should assign the load balancer. Let's wait. Maybe the backend load balancer is not. Yeah, perfect. Now let's see the logs. It's assigned, right? Let's see whether it works or not. It should detect for every 10 seconds. It will check. Let's wait. Perfect. Oh, failed to run once, soft error. Retrieval failed as a soft error. Still it is working. Why? Why? AWS config, do we still need to do something? I think yes. Let's go to EKS. Recently, actually they did something, okay? One more very important thing. Now, through this trust, we are telling IAM OADC provider that if this service comes and use, I am going to allow. But we also need to tell the service account, hey, you can use it. Okay. We also need to empower the service account. So we also need to tell the service account, you can use this. So here we told, if this guy comes, if the service account comes and use, you can use it. But how come the service account comes to know that it is attached with the IAM role? How come it comes to know? How come it comes to know? Whatever you did, the OADC provider is at the IAM level, right? But how come this service account comes to know that it can use it? So next is we also need to tell, okay. And we also need to ensure the service account is aware of the usage of the IAM role, okay. This can be by using pod identity association introduced in. This is pretty brand new concept, by the way, okay. All right. For this access, yeah. So EKS pod identity association is a method to associate AWS IAM roles to workloads. Okay. So they are telling, so create pod identity association. So you need to mention, okay, this role was created by me manually. So you need to create a role, then which namespace and which service account you also need to mention. And then you need to create. Then this particular role will have the needed role. All right. Let's delete. But one more thing, in order to use this, you need to have this particular plugin installed. So add the add-on. I think yesterday we have seen, right? How to list add-on. This we saw this yesterday. Okay. EKS pod identity agent. This is something we need to install. Okay. All right. Go and try to install this as well. Okay, this is another thing we want to install. Installing agent. Done. Now this should also install the needed agent. Now we need to tell how that will work. Okay, so let's see this. Once code is ready, that's it. We can make it a number of times. Okay, this should enable the add-on. the pod identity association, create a role. Okay, and I want this to be created for AWS EKS pod identity. Okay, done. Okay, so under EKS, I'm just doing it manually just to show. And then I want to give Route 53 complete access. That means I don't have to give these all these roles, right? Okay, this is not how it's working. Interesting. Okay, let's do it. Okay, Route 53. If I give Route 53 full access, I don't even have to do this inline policy. And then next, blah blah. Okay, maybe I can simply use this, right? Why do I need to bother? I don't need everything. I can simply copy this and I can use it. Okay, I don't need everything. Okay. Actually, I don't need this anymore. Okay, this is a waste of work. We don't need this anymore. Yeah, I think this is the latest way of dealing. Okay, using pod hide. Okay, so we are going through pod identity association. This is latest. Okay, whichever I'm not aware of it. Okay, in the last batch we tried something. Okay, yeah, again these things keep updating. If I do the same, if I watch the same recording after a year, there are 100 plus options that are coming up. Okay, we don't need it. So yeah, again I'm not over provisioning the roles. Okay, so these are the permissions that are needed, and this is how I'm giving the trust. Okay, I'm giving the trust. Okay, this means for this particular principle, mods.eks.service.com, session token service and assume role power I'm giving. Okay, all right. Now how can I mention the service account and this one? How can I do the pod identity association? How can I do the pod identity association? So I am creating the role that has the needed powers, which can be used by the pods, but how can I mention which pod? So how can I do the pod identity association? AWS IAM pod ident. Yes. Again, this is a brand new concept, by the way. Okay. So creates AWS EKS pod identity association between a service account in EKS cluster and an IAM role with pod identity. Okay, so that means you don't have to use annotations. Earlier we used to do the annotations. Okay, use AWS EKS pod identity to give temporary IAM credentials to the pods and the credentials that are rotated automatically. This is a great thing. AWS EKS pod identity association gives the ability to manage credentials for your apps similar to the way AWS is. Okay, if a pod uses a service account that has an association, AWS EKS sets the environment variables in the pod. Fine. The environment variables configure the web SDKs, include the command line variables. Okay. It's a simpler method than roles for service accounts, as this method doesn't use OADC provider. Additionally, you can configure a role for, oh, this is interesting. This I'm not aware. This I'm not aware. Okay. This is pretty brand new, by the way. Okay. Okay. So I need to tell who can use it. Pod identity association. bootstrap. The service account is role is, we have created the role, right? What is the role name? So technically we don't need OADC then. Interesting. Okay. All right. No worries. Done. So that means, okay, that means you are directly giving the association. Okay. That means you are provisioning the IAM role and then you are directly granting the role to the service account. That means this particular role is granted to the Kubernetes service account external DNS, which is available on the top of the kube system namespace of this particular cluster. This is fine. This is really nice. They really simplified it. Okay. What I want to do is I'll just I'll just uninstall it. Done. Start. Run it. This should install one more time. Actually, OADC is not really needed. Okay, the reason why it's not really needed is because they started using the pod identity association. That means you don't have to map all this. Okay, so go and tell OADC provider and all this is, they really simplified it. Okay, you don't even need OADC, but this will not work. Okay, if you are outside of AWS. If you're outside of AWS, then definitely OADC is the solution. Okay, keep that point in mind. If the pods that are running on Google Kubernetes engine wants to talk to a service on AWS, then the older strategy will still work. Okay, done. Why this is still getting that error? Why? Perfect. I think it's gone. Applying the provider records. Okay, perfect. Perfect. I think it's working. Okay, all records are up to the date, right? Now apply ingress. Get. Now the moment it updates, you will see this. Okay, the moment load balancer is assigned to this guy, obviously it creates a record. So directly it creates a record on Route 53. Let's wait. Perfect. It was assigned. Now look for the KLF. Okay, see, applying provider record filter for domains. See, these are the domains that it is able to see. Okay, now you can see, can you see this? Desired records. Okay, 3 records were successfully updated. for this particular hosted zone. Now you should be able to see this created automatically. Okay, so go and try to see this. Perfect. Can you see this? It was created. Perfect. And it should be the same. So it's A3 ACT AC8F2, right? You can also see AC8F2. Perfect. Now go and try to access it. You should be able to access it. Again, you'll get some default page or not found. It should be resolved. Okay. So are we clear? So guys, are we clear? Any questions on this? Okay, I'll deploy one more thing. Okay, and this name is expenses. Even this points to the same. Now what I'm gonna do is, again, it takes some time because the provisioning happening in the backend. What I'll do is vim-ingress.yaml. Okay, done. And the name of this is expenses and expenses. And just a proof, expenses is not there. Okay, it's not there. Okay, now I'll deploy it. Now the moment an assignment happens to this, okay, it provisions a record immediately. Wait for it. Can you see this? Perfect. So it's resolved. Again, you got a bad gateway because it's not accepting, but still it's resolved. Okay? Likewise, why didn't grant anything yet? Let's wait. Perfect. It was assigned. Now that means you can also see the record gets updated. Okay. Now go and try to check it. You'll see expenses. It's not a provision. Okay, perfect. Now it was updated. Now refresh. Can you see this? Expenses. Okay. You should be able to access it. Can you see this? Okay. Which can be accessed by this guy. Okay. I have not created it. Okay. Clear? Is it clear, guys? Now, when I'm doing the deployments, okay, for my front-end component or Prometheus or Grafana, I don't go and create manually. I create the cluster. I should get everything as is, okay? I don't have to worry about it because the bootstrapping should take care of everything. Clear, Rachit? Is it clear? Interesting?
Yes, Manoj. Yes.
All right. And if you delete the ingress, it should automatically delete the records as well, okay? Because delete -f. So in some time, it also deletes the records because those DNS records are no longer there. For every 30 seconds or 10 seconds, it refreshes. Okay. Again, these DNS records are more aggressively, they will never update. Okay. Once you update it, you change the application, not the DNS often. Okay. Again, that will be gone. Okay. So yeah, this is working. Now let's try to update our records. Now we are able to provision records on route 53 automatically using external DNS where IAM roles and trust are achieved. All right. That's it. Okay, next is installing Prometheus and Grafana. This is pretty much fairly quick. Okay. Yes, this is completed. And DNS, okay, this is also completed. Okay, this is also completed. Prometheus and Grafana should be coming up. Again, if you remember for expense project, we already did. So I'll just straight away go. Okay, we already know that. Okay, Prometheus stack. There is a stack. I think this is the one, Kubernetes stack. So Prometheus stack. Just scroll down all the way down. So this installs Prometheus stack, a collection of Kubernetes manifests. This installs Grafana and Prometheus rules combined with Prometheus using operator. See, operator is a resource on Kubernetes that offers custom resource definitions. Okay, you're using config map, deployment set, replica set as an object because they are offered by Kubernetes. For example, if you are an AI-based company called as Let's Rock AI, and if you want to create your own objects by using features of your choice, like just like how you use config map, secret, and bot resources, like if you want AI bot, chat bot, okay, voice bot resources. That means if you want to build your own resources, resource types, you use custom resource definitions, which you build custom resource definitions by using operators. Okay, it's a development related thing. Let's not worry. So you can install this by using Helm, and this chart is available in this particular repository. Okay, and we are adding this under this name, and then you can install this chart, okay, with the name of your choice, and you can see that this chart is available on that particular repository's particular path. Okay, so on this particular repository, okay, where you have added the name under that. Okay, this means you're adding a repository with the name Prometheus community, and you're installing it. You're telling under this particular repository in this particular path it will be available. Okay, so let's do it. It will be quick, by the way. Install Prometheus. Next is Bootstrap itself. Deploys Prometheus and a Grafana stack. Okay, again, this is also straight. I want this once pod identity association, everything is completed. So I also want to add this as a resource. Okay. Then at this point of trigger, again, I don't want this to be triggered all the time now. Okay. And repo add. This is a command. Done. Okay. And should be good. I'll just say from stack. Okay. Okay, we are installing a chart whose name is prom stack, which is available in this particular path. That's it. Okay. Now, again, this offers a lot of values. Okay. First, we'll deploy and see how it works. Okay. First, let's deploy. Deploying. Today I'll take 10 more minutes extra. Deploys stack. Okay, I should also be able to access it using HTTPS, okay? Because if you see this, we are already using ingress values. All the values are already supplied. Certificate is already provisioned. So it's HTTPS by default. Okay? Don't have any values. Let's take it off. Draft is also not needed. I just created for the saving the values to avoid screens. Okay. Again, my Grafana is dependent on the other resources. That's the reason I have added the dependency. Just a minute. Done. Should install the Prometheus stack as well. Perfect. I want this to be deployed on the top of Cube system. Okay, yeah. Helm. Okay, first case you get SVC. I want this stack to be in Cube system. Okay. It is deployed in Prometheus operator, but again, everything is cluster IP. That means I cannot access it from the external network. Prometheus, Grafana, I want this to be accessed from the external network. Okay, so first let's uninstall it because I want this to be on the top of Helm uninstall Tom stack, give system namespace. Let's make sure we do that. Okay. Done. But what I want is, again, this is a very, very, very big file, by the way. Okay. So if you start reading it, okay, it takes a lot of time. I really mean it. For the interest of time, I gathered the details and kept it. Okay. We can just mention ingress enabled is equal to true so that you get the ingress resource. Just a second, let me get that. Okay, you can get it. Okay, so for example, Grafana. Okay, inside the Grafana. Okay, so you have ingress or ingress enabled is equal to true or false. What is ingress class? Okay, and what is the host to use? All these things you can supply, but I'll just go through that. Okay, let me get that. Okay, just a second. I have it ready. Okay, just in the interest of time. Okay, just before the session, I spent some time. Okay, I went and crawled these values, and these are the values that I'm interested about. Okay, from stack. Done. Okay, so I'm telling enable Grafana, and this is the ingress class name. That's it. Now this. And I also want to make sure I just say done. Okay, I want to install by using these values as well. Okay, from stack values.ml. Done. And it's cube system namespace. That's it. Now let's go for it and apply. But you also need the ingress resource. Again, this takes a lot of time to go through, but we'll go through the shortest job first. Okay. My goal is to access it. That's it. Nothing else. Okay. This should deploy. Perfect. Get SVC. Perfect. You can see. No. Okay. Now you need to deploy an ingress resource. Okay. So again, I got internal resource as well, but at the same time, okay. Now I also want to have ingress resources. Okay. So what I want is, okay. This is the only place I'll compromise. Okay. To this, just say proof system hostname is okay. I'll deal this later with this dev today. Service it should go is this from stack cube Prometheus. So this is the service that it has to send, which works on port 8, which works on port 9090. Okay, done. That means if any of the requests, okay, so I'll just call it as Prometheus, which is available in cube system. Ingress class is this. If someone comes and hits Prometheus dev on my load balancer, I should forward the request to this. Done. Likewise, I also want to make sure I do it for okay. Helm apply -f. So if it is a prod, you supply the prod values. That's it. Done. Okay. You should send it to Grafana. From stack Grafana. Okay. You do it for the prompt stack Grafana, and Grafana is a service that works on port 80. Send it to 80. Done. That's it. You got it. So it should deploy the needed Ingress files. Let's wait. Again, rather than dealing ingress your way, okay, there is something running command AWS AKS skip configure helm to go ahead. Okay. So it's already there. So obviously it is failing. So how can I do helm upgrade --- install? Okay. Cool. So this means only installs that this upgrade install means if it is already installed, it just updates with the values that you mentioned. That's it. That's what it is complaining about. So now my cluster should have, when I create the cluster, it should have Prometheus, Grafana, Ingress controller, external DNS, certificate, trust, everything. Okay. This is how Kubernetes engineering teams in organizations will work, where the engineering team, Kubernetes engineering team will write all these things and distribute it to the teams within the organization. They can just use it. Okay. They call it as a Kubernetes engineering team. A lot of companies are adopting this culture. Okay. And that's the reason in organizations, when you're using charts that are offered by your companies, it takes time to provision because it has a lot of background bootstrap things that comes up. For what it is failing? Error running the command AWS update command. One minute, it was working till here. I want to see Casey get ingress CD2, I guess. Okay, it is creating. That means it is not the problem. What is the problem? Help-blessed. Okay. So stack is deployed. Okay. Okay. So Prometheus and Grafana. Perfect. Now the records are not yet assigned. For some reason, it is throwing error, but the job is really getting done. Okay. No, ingress resources are not created. It is complaining about something. Okay. Maybe I'll just mark it as true so that it won't throw error. Let's wait. The moment it creates the records, perfect. Now see Prometheus dev and Grafana dev should also be created. Go and try to refresh. You should also be able to see Prometheus and Grafana records. Perfect. Perfect. Okay, and it is also HTTPS. Seamless. Next is Grafana. So tomorrow, if I come to the class, I don't have to worry much, okay? Because I invested good amount of time in doing this. I really don't have to worry, okay? And the default credentials are Promo operator, if I'm not wrong. So sign in. You will be signed in. Perfect. Okay. Now, as a part of this, now I'm also getting, okay. Done. Now, I guess. Okay, that's it. This is also, the job is also done. So we'll see next, okay, what's next. And also, any questions on the top of anyone? This is something next. HPS stands for horizontal pod auto scaling. Okay, for this to work, cube control top nodes. Okay, cube control top pods. For this to work, what you need to do is, okay, metric server should be installed. Okay, if metric server is not installed, it cannot see what is the CPU utilization, what is the memory utilization. If that is the case, when you say scale the pod, if the CPU utilization is greater than 75%, first of all, you don't know what is the utilization of it. Okay, for that to work, you need to install the metric server. So for that also, you have a Helm chart. Metric server, AWS EKS. How to install? I think it's pretty straightforward. Okay, you just need to install it. Okay, let me complete this. Okay, just one thing. Done. And in case in future, if there are any new things comes up, it can still use. Okay. Done. Plus metrics error. Okay. This is something we already did this as a part of the expense. Okay. Done. Now run it. They should apply the metric server as well. No rule to apply the target. Oh, okay. Again, I can keep everything in a separate namespace. Now you can also see top pots is yielding the result because I have deployed the metric server. That's it. Now tomorrow, if I come and try to start, I get everything. Okay, so I don't have to worry much. Okay, I have Prometheus values here, Ingress values here, Ingress prod, Ingress dev, everything are here. All I want is just say I want. Okay, so 15 minutes before I run it, I'll get the cluster. Now on the top of it, I'll start deploying everything. That's it. All right. We'll meet tomorrow in the session, guys. Thank you. Thanks for staying up on it, because these topics needs to be mentioned in a single day. If not, the velocity will be diluted. Okay, that's for today, guys. Thank you very much. Any questions, anyone? Okay, all right. Any questions? Mahendra, Arun, Srilata, Shailaja, Rachit, Mridula, Mahendra, Girisha, Ambit. Okay, all right. That's for today. Thank you. Signing off.